İkinci oturumumuza başlamak üzereyiz. Ancak hala katılanlar var. Bir 5 dakika gecikmeyle başlamak istiyoruz. Çünkü arayıp katılmak isteyenler arkadaşların da olduğunu bilgisini aldık. Evet, burada sizlere sormak istiyorum. Birinci oturumumuzu nasıl buldunuz? Var mı yorumu olan, eleştirisi olan, nasıl olsaydı daha iyi olan diyebilen arkadaşlarımız varsa chat kısmından paylaşabilirsiniz yorumlarınızı, fikirlerinizi. Bu arada ben chat kısmını açamıyorum. Evet, yorum var mı arkadaşlar? Değerli katılımcılarımız, sabahki oturumumuzla alakalı yorumlarınız varsa alalım. Bir 5 dakikaya başlayacağız. Sabah söylediğim gibi bu oturumumuzun sonunda soru cevap kısmında sizlerle bir link paylaşacağız. O linkle alakalı kayıt yaptıran arkadaşlarımıza sertifika göndereceğiz. Sertifikamızda Amerika'da RES diye bir firma tarafından akreditedir. 2 PDH olarak da kredisi var. Umarım sizler için faydalı olur. Evet, en kısa zamanda sunumları paylaşmanızı rica ederim demiş Emre Bey. Emre Bey, paylaşacağız. Hem sunumları sizlerle paylaşacağız hem de YouTube'dan kayıtımızı İskit kanalından paylaşmış olacağız sizlerle yakın tarihte. Sunumlarda PDF olarak tekrar size mail olarak atacağız. Evet. Volkan Bey, sabahki sunumun Amca hizmet ettiği düşünmekteyim. Emeği geçen herkese ayrıca teşekkür ederim. Volkan Bey, biz teşekkür ederiz sizin firmanın da katkılarından dolayı. Benim açımdan sabahki sunum bir üretici olarak, tasarımcı olarak baktığımızda çok faydalıydı. Birçok konu netleşmişti. Bir takım hesaplarla alakalı karmaşıklık vardı. Onlar net olarak anlatıldı. Çok teşekkür ederiz. Evet, bir 2 dakika sonra başlayacağız. Var mı başka yorum olan? Evet, biz sabah söylediğim gibi biz direkt Air Movement and Control Association ile iletişime geçtik. Sunumlar Amerika'da hazırlandı. Ancak zaman diliminden ötürü bize bir Orta Doğu'daki bir arkadaşı tavsiye ettiler. Biz de baktık gerçekten bu konuda uzman kendisi. Sunumun yapılmasını o arkadaşa devrettik. Birazdan ben kendisini tanıtacağım sizlere. Evet. Kaan Bey, herhalde sayımız arttı. Yavaş yavaş başlayalım.
Evet, başlayabiliriz Aral Bey.
Tamam. Arkadaşlar, bildiğiniz üzere sunumumuz İngilizce olacak. Soruları tercihen İngilizce alacağız. Türkçe gelen soruları da çevirip sunumun sonunda konuşmacı arkadaşımıza soracağız. Ondan sonra da anketle sunumumuzu kapatmış olacağız. Çok teşekkür ederiz. Now I want to give the floor to Mr. Tanmoy Kumar CHOUDHURY. He's operation director in the Amca member company in the Gulf region. He is passionate in constant volume produce mission, airsoft product development, immense interest in fluid dynamics, CFD and CFX. Laboratory management in terms of airflow and sound. After sales troubleshoot, HVAC product sales management, and 14 years in fan technical and RD departments experience. Mr. Tanmoy, the floor is yours. I stop my share. You can stop your presentation, and we will be listening to you.
Thank you, Mr. Arel. It's a pleasure to be here. I will start my screen. Is it visible? I'm audible. Thank you very much. So, system effect on system flow and pressure. Their estimations and calculations we'll cover today. Their impact on fan performance curve will be presented here. And this webinar introduces a system effect and how to calculate the additional pressure requirements to compensate for their losses and maintain the flow that you require. Then we will identify practices to avoid system effects, few examples to visualize turbulences inside the fan and system. I will try to visualize, use a tool called CFD. And then we'll talk about fan selections, fan curves, and fan energy index also will be reviewed. So my heartfelt welcome to all dignifying guests. My sincere gratitude to Skid and the platform to discuss topic like this. So as you said, we have done everybody on a mute mode. There will be a question and answer session, and then obviously this presentation is recorded and can be part of your later review. There is a PDH credits that I think Mr. Arel will explain later, and then we'll have some question and answer session at the end. So you can even type if you like in the box so that we can address it even during the talk, or I prefer to be at the end so that we address one by one. So this part is, as you know, as a part of a certified of completions of a certificate to be issued. There will be a link put into your chat box. You can review that later. This is the copyright material, but few of the slides will be available for your review. Without a reproduction and distribution, you need Amca approval, including ISCAR. As you know, I was part of the HVAC industry for 14 years, and my passion is all about fluid dynamics. So I will try to give you some kind of a thought that I used to do and I love to do and to present to my clients. Hope those practices will be useful during the discussions. So my agenda will be, I'll try to introduce Amca because Amca is a known name to all of you, but I'll try to do touch the topic a little bit. And then I will cover the CRP program, which is called Certified Rating Program. And then the main topic is a system effect. And then obviously we'll have closing sessions with question and answer. At the end, this presentation will let you know how to identify system effect using Amca publication 201 and the impact of fan performance curves. You were able to calculate system effect on fan inlet or outlet. and the systemic impact on your power consumption, identify practices for avoiding system effects, and then visualize turbulences at fan inlet and outlet using CFD tool. So introduction to Amca. As you know, their prime mission or prime focus is advocacy. The 80% of their part is the certifications, and then they do educations like a seminar that we do right away. So our global reach is we started as a company as in collaborations with few manufacturing company in US. So right now the strength is 169 in North America. Then Latin America we are 8 as a member. Europe we are growing. We have a separate chapter there as 28. Middle East is a very promising chapter. We have a separate director who look after this market. I'm working as a marketing committee here, and we have 27 members. And then in Asia, it's a really faster growing member among the continent is 151 till date. So scope, just to give you a glimpse, we cover air carton certifications, then fans for residential and commercial, fans for fire smoke control, fans for industrial processes, for power plants, fire and smoke damper, fixed and adjustable louvers, and so on. So if you talk about the value chain as Amca, we provide members with an international standards and publications. We do have our testing chamber, and we do also accreditation CRP program, even laboratory accreditation program. Obviously certifications and rating program part of the standards as well. Then we do a lot of advocacy, industry relations, and marketing and educations to promote as a value chain towards focusing more on certifications to the systems, including product together, and then how that product going to behave in a real scenario. So in terms of advocacy, there are legislative and regulatory body, we are part of it. We do have our own standards development process, publications, white papers, everything is part of the website. Industry relations is one of our major advocacy program. In terms of educations, internally and externally, we'd like to promote the idea that today I'm going to present is generated by Mark. Is an executive director in Amca. So we like to focus the areas that people are actually facing in a system and how to address those areas as well. So we do a lot of conferencing, we exchange a lot of tools, we share our knowledge, we try to transfer the past experience, especially what went wrong and what went well through the process, including building a new standard, setting a new laboratory, or working with some regulatory body, let's say ISO 5801 and so on. So everything is part of our website. It's a very dynamic website. So if you like to see who are the part of our certifications, who are certified, what are their efficiency, and so on. So easily a navigating tool. You can navigate wherever you want. Is a program. It's an educations, wherever you like. Who are the members? So full kind of a dash available if you can visit www.amca.org. So I will touch a little bit of Amca certified rating program, and especially when you see the building owners should know their equipment is working day in day out efficiently or not. So air system products are not certified are subject to heavy services and energy cost. That's why Amca Movement and Control Association, which is Amca, started this certified rating program. So if you see how you started, let's say if you have a system, there is a problem ensuring product claims in their data sheets are actually meeting their standard or not. And the solution is find a global standards and the performance along with the testing, third-party independent verifications. And then what you realize, there should be a standard and rating program that could be merged together. And then that's how you get a peace of mind that product claims to be achieve their performance, which is rated. And the result is more level of playing field and enhanced confidence, especially in product performances. So why specify products? I could see is apple to apple comparison. This is very, very important. And then you get a clarity before you buy any Amca certified products. Also, it includes reliability and the ratings. Catalogs are up to date because most of the time it's very difficult for a client, especially, to understand what they're buying. It's up to the date as per the third-party certifications program. And then Amca has a checking testing, ensure that the manufacturer maintaining their the values within the tolerance limit as per Amca 111. So the process of CRP is very, very simple. First you apply. Once you have a, let's say, family of products, and then the Amca going to review. They're going to pick the samples, and then there is a review program for the standards, which standards is led to. And then there is a testing certifying process, and the authority will verify it. Then you see yourself as a part of the website, and you officially get a seal, which will be quite similar to these, whether it is air performance, air sound, or FEG, or it's a wind-driven rain, or a Santa Bluer certifications program, whatever. But it's all part of the Amca website. You can easily navigate through the same channel. So we have test laboratory all over the places. As Amca headquarter, we have our own test laboratory. We have another laboratory in Intertech, which is also a created part of Amca process. CTR in France, and then Dubai, we have a Thomas Bell Wright. Amca, we have in Malaysia a presence. And then in Korea, we have a KPC. So these are our certifying labs around the world. So audit mechanism is very simple. We have an independent testing body, and then no bias towards any human manufacturer. Amca members are non-members alike are eligible to participate in the CRP, but it's better to be part of Amca membership. Amca standards of application describe how the product is tested and rated. The document have been created with volunteers from all aspects from their movement and industry. So the publications are reviewed by manufacturer, so that it's not a surprise to anyone. Once the product certified, ongoing verification is conducted by Amca through repeated check test. Even if you have accredited laboratory, they ask for repeated check test. Over a period of several years, product failure during any check test requires product inspection, recertifications, and withdrawal as well. Refusal to comply with Amca check test or failure to make the required product corrections can result in product suspensions or CRP violations. There is another category in Amca website. You can easily see who are violating. So we are very much clear and crystal clear. We need to be transparent with everyone, and that is also part of Amca policy.
Sorry, Mr. Tanmoy. Sorry for interruption. There is a problem in the sound. Would you check your microphone? It's crashing in the sound.
Is it okay now?
Would you speak again?
Is it okay now?
No, it's continuing. Do you talk with microphone or with the computer?
Okay, let me try something else. Is it okay? Is audible?
Yes, it's so good. Thank you.
I'm audible, right? Okay. So let's start with fan system effects. We'll start with a quick check about fan safety. These are moving parts from and that can injure. Aside from the obvious hazards of the fan wheel, there are hazards of the drives, electrical components, shaft coolers, and those hidden dangers. Lockout and tag out equipment to protect yourself and others. Do not increase the speed or over operating temperature of a fan above the manufacturer's limit. Amca publication 410 is available for free from Amca website. So for our review of system effect, we made a basic air moving systems with some standard components, which is workable with slotted hood. Then we have a deep tank with slotted hood. Then we have a air washer scrubber. We also call it pollution control unit. And then a centrifugal fan. Obviously associated ductwork. And the calculation duty point is 15,000 CFM, which is 25,500 meter cube per hour. 6-inch water gauge, which is 1524 Pascal at 1.2 kilogram per meter cube density, approx 21 degrees centigrade is standard. System effects neglected, as you see from the picture. Not shown replacement air in the system into account and not shown here. So fan selection is automated and available from many manufacturers' software over the internet, desktop version. A review duty point at 15,006 inch, which is for 15,000 at 6-inch water gauge are 6 fans providing the required flow and pressure duty point. Although this model shown are only one model type, which is backward curve only, just for simplification. There could be acceptable airfoil, industrial exhauster, forward curve, and other blade style selections. It seems easy at first, punch in the flow and pressure, and selections pop out. This is a short list. The list could be much longer. It's like searching a range on Amazon. A list of selections. A lot of selections overloaded. There are many factors that will influence fan selections. Here are those same fan selections curve, all plotted on the same scale. All models are going through the duty point at 15,000 CFM at 6-inch water gauge. In this curve, only one power curve is shown for the size of 33-inch backward curve. Making fan selections can be more difficult, but the new matrix fan energy index, which is called FEI, will help make more efficient selections. Fan energy index compares fan based on the duty point and the fan's ability to hit the duty point and its horsepower at the point. Fan energy index is a rating of a fan power requirement compared to an efficient fan for the same point. Fan energy index calculation method are covered in Amca standard 208. which was approved by Amca international members in 2017. The standard was approved as an American national standard on January 24, 2018. Also part of ASTRAE 90.1 2019 and ASTRAE 189.1 2020. The fan energy index is an application dependent metric, meaning that it encourages right sizing fan so they operate more efficiently at optimal efficiencies. FEI allows comparison of fan for a particular applications. FEI is replacing fan efficiency grade. We call it FEG in model codes and standards. FEG is only an indicator of a fan's general peak efficiency. FEI is referred as in ASTRAE energy standard for building except low-rise residential building. ASTRAE 90.1 2019 is FEI greater than 1. FEI is proposed in ASTRAE design of high-performance green building ASTRAE 189.1 2020, which is FEI greater than 1.1. FEI is proposed for International Energy Conservation Code, which is IECC 2021, which is FEI greater than 1. FEI has many useful characteristics when sizing and selecting fans. Note our duty point. The duty point used to calculate an efficient fan power requirement, the fan electric power will be FEP, which is here. Then FEI is equal to 1 will be signifies compliance with the regulations, and FEI less than 1 will be non-compliance. FEI greater than will be over-compliance. Notice here that FEI changes with impeller size and is highest at fan size 33. Where the fan has the highest total efficiency and the FEP actually is lowest. FEI is the reference fan power divided by the actual fan power. So fan curves include a lot of information and can be confusing. So every fan type and size has a unique fan performance curve. There are a lot of information on the fan curve. First is a flow versus total pressure, flow versus static pressure, flow versus power, system flow versus pressure, flow versus efficiency, static or total, and then fan energy index versus flow. Additional data on the curve, model, size, diameter, RPM, density, and few notes, Amca certifications, bribe losses, speed, density, outlet area, how the fan was tested, and how fan energy index was calculated. Select a fan which will generate the required pressure at the desired flow. Manufacture test fans with good or ideal inlet and outlet conditions to get maximum performance from the fan. The design or installation of the fan into an air system may require other than good inlet or outlet connections. The fan performance will be impacted by the duct connections. As you know, system effect occur because of differences between fan inlet and outlet connections. They used in laboratory tests to obtain the fan performance rating. Fan publication 201, which is fan and systems, gives specific detail on system effect related to fans. I think section 4.5 and in these publications. An ideal inlet condition allows the air to enter uniformly without spin or in either direction. A spin in the same direction as the impeller rotation, we call pre-rotation, reduces the pressure volume curve by an amount independent upon the intensity of the vortex. The system is similar to the change in the pressure volume curve achieved by variable inlet vents installed in the fan inlet. The vents induce a control spin in the direction of the impeller rotation, reducing the airflow, and then a counter rotating vortex at the inlet may result in a slight increase in the pressure volume curve, but the power will increase quite a drastic way. Obvious changes that affect fan performance are density of the air or the change in speed of the fan. System effect is intended to address and estimate the impact on the fan's actual performance versus the laboratory tested performance. Amca publication 201, it's called Fan and Systems. It published, I think, in May 2020, revisions. In the review and revision process is still going on. The system effect factor is a value that accounts for the effect of conditions influencing fan performance when installed in a fan system. So an example of a system effect cause could be an elbow adjusted to the inlet of the fan. Even if the friction loss of the elbow was properly accounted for, the proximity of the elbow to the inlet of the fan adversely affect the fan performance. The change in the system performance is more than the additional of the friction loss of the elbow. In this example, we have a centrifugal fan with a straight inlet as shown. The fan performance would be as per manufacturer's standard curve. The fan must be installed with an elbow on the fan inlet as per site restriction. The fan, the air into the fan no longer uniform, and the fan air performance is restricted. This result is a new fan curve. The fan operates at the intersection of a system curve and the altered fan performance curve. If system effects is neglected, there will be an airflow deficiency. Amca publications 201 provides methods and formulas to calculate the system effect. In this example, we have a centrifugal fan with an elbow installed on the inlet shown. An inlet elbow is installed directly on the inlet of the fan. The fan is shown with an two-piece metered elbow. And the fan is shown with a smooth 1/R/D elbow ratio. The publication includes example of inlet and outlet conditions of many fan types. Here are two tables for the inlet of the centrifugal fan. Table, I think 9.4a is of two-piece metered elbow, not vane. 9.4b is of three-piece metered elbow, a little bit compressed here. 4 or more piece metered 90-degree elbow sections, not vane. And the system effect curve. Identifies for the 5-piece metered elbow which is R. The system effect from the previous example is identified as curve R and S. The system effect is velocity related. The system effect should be calculated based on velocity at the fan inlet or outlet, and the coefficient of the curve on the figure Table 7.1 includes dynamic pressure loss coefficients for each curve to facilitate calculations of the system effect using the formula provided. The curve R coefficient value is 1.2. Calculate the area of the inlet and the inlet velocity to directly calculate the system effect using the formula, or you can use a log graph, whichever is possible and comfortable. We'll go over these methods in more detail. So the inlet area is 4.1. Sorry for my IP here. So feet square. Inlet velocity is 3056 feet per minute. Using curve R on figure 7.1, we find the intersection at 3056 feet per minute. So we read horizontally to the left the system effect of 0.7 inches water gauge at standard density 0.05075. So same 4.91 inlet area, velocity 3056 feet per minute. Using our pressure curve, dynamic pressure loss coefficient 1.2 from the table 7.1. If you use this same formula, you're going to arrive at 0.7 inches water gauge. So note on the curve, system is the velocity related and is calculated from the velocity of the fan inlet and outlet. Calculation have been for flow point, and the system effect can be calculated for each point of the fan using this formula. So the formula for calculator of loss at the duty point can be applied to each point, which here is R1.2. Pressure loss is calculated for each flow point using the same method. So we get a complete list at different CFM, different pressure. So here are optional original performance curve, solid green line, and the performance curve with system effect considered with a dashed green line. The duty point required is 0.1. The flow and pressure will be at 0.2 with system effect on the fan inlet. The difference from 0.1 to 0.3 is 0.7 in the system effect. As velocity increases through the fan, the effect increases because you're increasing more turbulences. So the primary difference between inlet and outlet system effect is the outlet system effect, the elbow profile, not fully developed after the fan. Or system effect acts as an additional pressure loss on the fan outlet due to high turbulence into the fittings. So the blast area versus outlet area, in this case, we have 0.8 from manufacturer catalog. Outlet velocity is 2377 atm. So without an outlet duct, the velocity profile cannot be even out. High velocity cannot be recovered to low velocity systems. By definition, 100% effective duct length is a minimum of 2.5 equivalent duct diameter. That is 2.5 times of a duct diameter. For velocities greater than 13 meter per second, which is 2,500 APM, add 1 duct diameter for each additional 5 meter per second velocity. For a strict no elbow outlet, we use in table 8.3 as per Amca, from Amca 201, and the blast area to outlet area ratio is 0.8 from the example. The velocity from the example is 2,377 APM. The flow is 15,000 CFM. Working backwards, the duct area would be 6.31 square feet. The diameter at duct with area of 6.31 feet square is 2.83 feet or 34 inches. So the length of the duct to be 100% effective, which will be 85 inches. In the duct, if the duct was square, then the diameter would be 30 by 30, then the length will be 75 inches long. Graphic representations of an additional pressure requirement for outlet system effect. Selections for operating at point 1 without considering elbow on outlet. The calculated system effect add resistance to the system, equivalent at flow going from 1 to 0.4. The fan is operating will deliver at point 2 with less flow and higher pressure than the original duty point. System or fan must be changed to deliver the required flow. So without an outlet duct, the velocity profile cannot even out. High velocity cannot be recovered to low velocity streams. Elbow positions matter to how much it disturbs the fan flow profile. For an elbow on the outlet, we use table 8.5 from Amca 201. And the blast area to outlet area ratio, we know it's 0.8 from the example. In our example system, we have a fan with no duct and an elbow in position C. Blast area elbow C with no duct, which is 0.8 Q and R. And 100% means no system effect factor identifications required. A similar calculation is made for the outlet of the fan. There is an advanced copy of the new log graph to be included with the revisions for the example that you see in the new publication. In this case, we use 30 inches square feet outlet of 6.31 feet square and 15,000 CFM. So in the Q, we have 1.5. If I use the formula, so we get outlet system effect at 0.53. So here is the original performance curve, solid green line. Then the performance curve with system effect considered with a dashed blue line. The duty point required is 0.1. The flow and pressure will be at 0.2 with system effect on the fan inlet. And obviously, sorry, this is outlet. And then the difference point from 0.1 to 0.3 is 0.53 is system effect. As velocity increases through the system effect, obviously the effect will also increase. So this here is an original performance curve. Again, green line. And the performance curve is system effect considered with the dashed red line. The duty point required is 0.1. The flow and pressure will be 0.2 with system effect on the fan. The difference is 1.23. So the actual scenario is 7% deficient in flow. So outlet system factors, if you talk about inlet system effect factor and outlet, there are outlet ducts, outlet diffusers, outlet duct elbows, turning vanes, volume control damper, duct branches. Similarly, in inlet system factor will be inlet ducts, elbows, vortices, inlet turning vanes, airflow, straighteners, enclosure, obstructed inlets, and so on. Factory supplied accessories like supports fan inlet, drive girds. If it comes of axial fan, belt tubes, inlet box, damper, or VIB. Original design, ignoring fan system effect, is a solid fan curve line from the manufacturer. And then measured system performance. Note that ACF changes the performance of the fan. So this point does not lie on the original fan curve. The difference of system effect at the operating point that must be added to the fan pressure requirement. On the fan curve, in this example, the data test points are shown. They align at a particular flow volume or along a parabolic system fan law curve. Original design point with ACF taken into account on fan curve, adjusted for fan system effect and RPM. Note that the fan speed needs to be increased to meet the desired airflow rate. The power could be increased by the increase ratio, cubic percentage. Recommended changes to the system to avoid system effect. Turn the air washer or discharge 90 degrees to facilitate spacing of the equipment. Added straight inlet duct with the long radius elbow at the fan inlet. Change fan discharge position from top horizontal to upblast. Added some transition and outlet duct to fan. So before we touch the speed change, what measure can be taken to reduce system effects? So turn the fan without elbow, if possible. Change the design positions of the fan to remove elbow. Add no loss stack fan. Add turning vanes at elbow. Before committing to spending on energy for the life of the system, evaluate the alternatives. If you must increase the speed, remember the fan safety practices. Can you take other measure to eliminate the system effect? And always check manufacturer recommendation before you touch the fan at speed, because there will be critical speed limitations and the maximum speed related to it. The fan laws can be used to generate new fan speed to provide the required flow or pressure. The fan laws can be used to estimate the new power curve. Power will be changed based on the speed change cubed. In this example, the speed increase is 7.4%. The power is an estimate by the state fan law. The power increases, which is 1.24 at 24% increase from 19.7 to 24.4 bhp. The operating point on the curve changes slightly, which accounts for the difference. The FEI reduces from 1.27 to approximately 1.05 based on system effects. So I have assumed only the elbow losses, keeping same RPM as 1205. Number of blades, 10. 3D model and CFD done as per laboratory test with effective duct length. Results from the original installations without EDL, which is almost 7% lower than design air performances. Design change to elbow, a design change to allow more air at fan inlet. Fan orientation changed to a blast, and then uniform velocity achieved with EDL. I have added a small video to visualize. This is an example of one pollution control unit installed but not achieved catalog performances. The performance of the unit as per the duty point is 11,500 CFM at 750 Pascal. But the site measurement elbow is still at 10,355 CFM. Even after drive adjustment, it's even dropped 10% more. The CFD output, as per the study, the output velocity dropped from 2108 APM, which is 10.7 meter per second, to 9.1 meter per second of the blower, and resulting 10,355 CFM flow rate. In this case, the obstruction of the airflow are inlet and outlet plenum with immediate elbows. Then there's a proposal that straight duct with plenum gives better performances of the blower and increases the outlet velocity. Increasing fan RPM may result in more turbulences and produce more noise as well. And also the inlet should design to modify in such a way that the velocity drop should not vary very drastic. So you can easily visualize the point here, a lot of turbulences, which in terms of system factor. If you increase the velocity, and then that means you're increasing the turbulences. So system effect changes the fan curve and increases the power required, fan speed and noise. System effect has to be accounted to get the required flow from the fan. When system effect is accounted for, the flow should be as specified. These ratings are found in catalog of certified products. For certified products, it's mandatory to include this statement so that user know how the fan was tested and whether it matches how the fan will be installed. The fan curves used in this presentations are based on the fan laws and calculations. Few rule of thumb, avoid system effect. The first one is 2.5 duct diameter on outlet. Minimum 3 to 5 duct diameter on the inlet. And avoid inlet swell. Take into account that the total cost of the building is the original capital cost plus the cost to operate it. System effect cost, operating energy and noise. There are some recommendations. So first is allow enough space in the building design to allow for appropriate fan connections to the system. Use allowances in the design calculations when space or other factors dictate less than optimum arrangement of the fan outlet and inlet connections. This recommendation is if you can't avoid system effect, then take them into account in specifications for the flow and pressure, or select the fan with specific system effect calculated in the fan curve. The third one is include adequate allowances for the effect of fan of all accessories and apparatus on the performance of the system and the fan and the system and the fan belt drive loss, VIVs, and fan current and so on. So system effect can be identified in the design stage. System effect should be minimized in the design stage. System effect will change the performance and required power of the fan. Estimates of system effect can be calculated for a point or curve. Resources, system effect are covered in detail in Amca publication 201-2. It's called Fan and Systems. There is a variety of resources for system effect, including Amca, ASRE. There will be the final question session after this. So as I told you before the presentations, there will be kind of a survey on your chat box. Feel free to add your details. Is there any question I can answer?
Thank you, Mr. Tanmoy. It was so enjoyable presentation. Now we share the survey link for the certification with our participants. Up to now, I don't receive any questions, but in meanwhile, I can ask you some question. My question is about the Amca audit mechanism of the certified products. We, as manufacturers, we encountered with some problems, although we respect the rules of the fan assemblies and taking account the system effects of the fans, geometry effects and similar issues. We encountered with some failures in the fans, especially which fans are located into a casing, for example, in the handling units, in the test results. So we wonder if this manufacturer is Amca certified, why the DLL datasheet is not in line with the test reports, which we are doing in our own performance laboratories or with third-party laboratories. Do we have a comment regarding this issue? How is the audit mechanism of Amca certified products in the world? How Amca audits the quality of the fans or manufacturing in the market?
That's a good question. That's normally they have an audit mechanism for sure, as I started my presentation. So if your product is certified, Amca normally pick within a certain time frame as a random model or diameter from the range, and they verify as per Amca 111 with a tolerance limit, which is 1.25 versus 2.25 ranges. If that fall, then they will continue with their certifications. Else, they're going to ask for a new test for changing even their catalog, even publishing in their websites. So there is a proper method enabled in Amca, and if the client wanted to verify whether the fan is tested and certified, or the seal they are applying, whether valid with FEG and FEI grade, they can directly contact Amca, and they will obviously get back to those client or concerned persons with the proper feedback, how the fan tested, how the rating published, whether data is validated or not, and so on. But the point is, when you put a fan inside a cabinet or air handling unit, obviously you know there will be a system effect occur because there's a certain standard to be maintained at inlet and outlet. So if that meets, then obviously you're going to achieve catalog performance. But normally, what I do, I use, if I have a doubt for anything, I'll put it into CFD model and analyze it, whether the fan getting developed air or fan inlet. Normally, the fan efficient performance based on fan inlet developed air, which is not 100%, as I told you, effective duct length. So if there is no effective duct length fan inlet, or if the fan is not getting air at fan inlet, then it differs most of the time. But Amca do have a proper check process.
Thank you very much. I've received one question. Mr. Tanmoy, can we talk about the system effect in the free inlet, free outlet fan test laboratory? For instance, Amca 210 figure 15 testing rig.
Yeah, figure 15 is probably, as you know, it's called roof fan, or normally we use as an inlet duct outlet free. But if it's a, there is, I think, only the propeller or kind of an, we call it plate mounted fan. There is inlet free and outlet free. But in figure 15, normally always there is a duct at the inlet, whether you put it on the wall or you put it on inlet duct. So if you're testing in figure 15, obviously there will be no system effect. But if you test in figure 15 and put into real scenario, there obviously a chance that if you avoid, or if you're keeping 25% of effective duct length, then need to consider those factors. But the curve and everything is available in 201, that you can refer.
And it continues. Is there system effect, or is it a perfect system without system effect?
Yeah, that's a very good question. So we wish that we have a system like this that can easily achieve catalog performance. But in real scenario, you hardly get ideal inlet 100% in 2.5 duct or 3.5 duct meter. So it's very, very rare occurrence. But if the building owner or the designer are fully aware of what is going to happen, whether they have space limitations or they have different challenges at the roof or at the fan room, and then they normally consider as losses into their internal static pressure calculation, so that they overcome during commissioning. But in real world, there is nothing called ideal or zero system effect.
Thank you very much. I think there is no other questions. So if there is no questions, we are going to finish our activity. Mr. Tanmoy, thanks for your and Amca's contribution in our webinar activity. It was so useful for our engineers active in our market and this region. I start to speak Turkish, sorry. Değerli katılımcılar, katılımlarınızdan dolayı çok teşekkür ederiz. Sorularımız oldu, sorduk. Birinci oturumda biraz daha çok cihaz içi fan uygulamalarıyla alakalı bilgiler aldık. Bu ikinci oturumumuzda biraz daha genel, hem cihaz içi hem cihaz dışı ve saha uygulamalarla alakalı bilgi aldık. Biliyorsunuz her şey sistem efekt değil. Fanın belli bir kuralları var uygulamada, onları dikkat etmemiz gerekiyor. Sonra varsa sistem efektlerimiz, onları hesaplayıp hesaplarımıza dahil etmemiz gerekiyor. Maalesef sahada görüyoruz. Bazı problemler oluyor. Bazen müşteri talebi üzerinde yer problemlerinden dolayı olabiliyor. Ancak atladığımız konular oluyor. Bazen de aldığımız fandaki DLL test verilerinden gelen bu belirsizliklerden dolayı bazen failler yiyoruz. Umarım faydalı olmuştur. Bazı dikkate alacağımız konular muhakkak vardı, en azından benim açımdan. Tekrar katılımlarınızdan dolayı teşekkür ediyorum. Eğer başkanım da burada, Melek Hanım da, Kaan Bey'in de başka yorumu yoksa müsaadenizle kapatmak istiyoruz. Başkanım var mı?
Ben çok teşekkür ediyorum Aral Bey, başta size, emeği geçen bütün arkadaşlara. Gerçekten çok detay, teknik bir konu. Konunun uzmanlarından dinleme şansı bulduk. Bu konuları her zaman doğru kişileri bulamıyoruz, doğru bilgileri alacağımız insanları bulamıyoruz. Bu tür aktivitelerin devamını diliyorum. Katılımcılardan da gördüğüm kadarıyla gerçekten konuyla ilgili insanlar bu oturumu dinledi. Eminim faydası olacaktır tasarımlarında, projelerinde, Ar-Ge faaliyetlerinde. Çok teşekkür ediyorum. Bir de Mr. Tanmoy'a isterseniz bir teşekkür edeyim. Mr. Tanmoy, I would like to thank you for your presentation. It's really very technical, deep technical. So I hope it will be helpful for the designers in our HVAC industry. We were heard about system effect, but to be honest, it's my first time that I listen it very deeply with your deep knowledge. I would like to thank you a lot. And when this pandemic situation overs, I would like to invite you to Turkey to make a longer training for our all participants, all our engineers in İSKİT, all our members. Thank you a lot, and I wish you a healthy days and stay alive without any system effect.
It's a pleasure. It's a pleasure. It's really a great platform on system.
Thank you.
Başkanım, sizin desteklerinizden de dolayı çok teşekkür ederiz. Umarım önümüzdeki yılda da bu benzeri teknik detayları içeren sunumları komisyon olarak devam ettiririz. Herkese çok teşekkür ederim. Hepinize iyi günler, sağlıklı günler dilerim. Bir dahaki etkinliğimizde görüşmek üzere diyorum. Hoşça kalın.